In 1701, Jethro Tull patented what history calls a revolutionary invention, a machine that placed seed at controlled depth, transforming agriculture. The Sumerians engineered that exact machine 3,500 years earlier. It cut seed waste by up to 75%, pushed germination near 80%, and generated the surplus that built the first cities on Earth. Then it was erased from history. No one can fully explain why. Southern Mesopotamia's first farmers faced a brutal arithmetic. Every planting season, they scattered barley and wheat by hand across fields left moist by the receding flood. The numbers were unforgiving. Archaeobotanical surveys at Abu Haba and Eridu show that broadcast sowing left 150 to 250 grains per square meter on the surface, but as much as 45% of that seed never produced a stalk. Birds, wind, and shifting silt carried off nearly half the crop before it ever sprouted. Germination rates hovered at 55 to 65%, sometimes lower if the rains failed or the silt crusted too quickly. Weed seeds, carried by the same wind, took root in the exposed layers, crowding out the barley and signaling a field's vulnerability. The surface was a battleground. Anything not buried at the right depth was at the mercy of weather, animals, and chance. Population models for the Ubaid period suggest that, with losses this high, a village of 200 people could barely sustain 4 hectares of crops. The ceiling was set not by land or water, but by the limits of human hands. No matter how hard they worked, waste was built into the system. For these early farmers, every harvest was a gamble against nature, and the odds were not in their favor. A handful of ancient objects hold the answer to southern Mesopotamia's agricultural puzzle. The British Museum cylinder seal BM 104456, carved around 2600 BCE, shows a pair of oxen dragging a wooden beam across a field. But what sets it apart is the narrow tube running beneath the beam, a feature echoed on the Louvre AO 23678 seal and a limestone relief from Eridu. This slender conduit, just 30 centimeters long and barely the width of a finger, is not decorative. Its position and proportions match the requirements for a gravity-fed seed delivery system. A small hopper perched on the beam would funnel barley through the tube, releasing it directly into the freshly cut furrow. The beam itself measures about 120 centimeters, hollowed to reduce weight, while the share bites into the soil at a fixed angle. The driver's job is not brute force, but precision, guiding the oxen, watching the tube, ensuring the flow of seed is steady and even. Each component, the beam, the tube, the share, and the hopper, works together as a single mechanism. The result is controlled seed depth, regular spacing, and a dramatic cut in waste. What these artifacts show is not a guess or an accident, but a machine designed for efficiency. For the first time, the boundaries of human labor are set by engineering, not by chance. A single clay tablet, catalogued as BM 33112 in the British Museum, distills the logic of Sumerian agriculture into a set of commands that could have been issued by a modern engineer. This so-called Farmer's Almanac, written during the Ur-3 period, spells out not just what to do, but exactly how and when to do it. The scribe instructs the plow to a depth of 2 centimeters, no more, no less. Wait for the canal water to settle at precisely 1.4 meters before sowing begins. The window for planting barley opens in late May, timed to the lunar cycle when the receding flood leaves just enough moisture in the soil. These are not rough estimates. They are quantitative thresholds recorded in cuneiform that governed the work of thousands of laborers across the fields of Umma and Ur. The technical language is striking. The term kusag, glossed as seed spreader, refers to a specific wooden implement with a perforated base designed to release grain at a controlled rate. The tablet even includes a clause for water level monitoring, a bureaucratic safeguard to prevent premature sowing. Lexical lists from the same era cross-reference these instructions, reinforcing the impression of a standardized, state-backed protocol. This is not myth or ritual. It is the machinery of administration, ensuring that every furrow, every seed, every drop of water conformed to an engineered system. Here the scribe is not a poet or priest, but a technician, writing the rules that would feed a civilization. Replica trials in the fields of southern Iraq have put the Sumerian cedar plow to the test. The results are not just impressive, they are transformative. Modern reconstructions modeled on measurements from the original copper alloy seed board at Tel al-Ubaid show that the device delivers seed at a uniform depth of 2 centimeters, spaced precisely 4 centimeters apart. In these trials, barley germination rates reach 78%, an increase of more than 20 percentage points over hand broadcasting. That single leap means thousands more plants per hectare, each drawing water and nutrients from the right layer of silt. Seed waste drops by as much as 75%. Where hand sowing scattered grain to the wind and birds, the plow's gravity-fed tube buries each kernel out of reach. The field becomes a grid, not a gamble. Yields climb by 0.8 tons per hectare, a figure that, in the calculus of ancient society, means surplus. Surplus that can feed a standing army, fill a temple storehouse, or support a city's scribes and builders. Labor costs fall just as sharply. 2 men and an ox can sow a hectare in 2 hours, a third of the time required by hand. The numbers are stark. Less seed lost, more grain harvested, fewer hands needed. This is not the mark of a crude tool. It is the signature of engineering. The Sumerian cedar plow is a system, not an accident. Its logic, measured, repeatable, efficient, translates into calories, into security, into the very possibility of urban life. Yet the device vanishes from the record after the fall of Sumer. For 3,500 years, the knowledge that once fed a civilization is lost, its inventors unnamed, its impact unacknowledged. The machine that built cities disappears into silence. And so, a technology forged 5,500 years ago, reinvented millennia later, has never been properly credited to the world that first imagined it. After the last Sumerian kings lost their grip on the southern plains, the record of the cedar plow fades almost overnight. Cylinder seals and reliefs from the early dynastic period, once crowded with images of oxen, beams, and slender seed tubes, give way to simpler scenes, plows without tubes and farmers scattering grain by hand. The visual signature of the machine vanishes from the archaeological layer. Not a single documented seal, tablet, or relief from the Old Babylonian, Kassite, or Neo-Assyrian periods shows the device. The technical vocabulary, Kusag the seed spreader, drops out of administrative texts. Even the farmer's almanac style of precise, quantified instruction dissolves into more generic references. This is not a slow decline. The loss is abrupt and total. The knowledge that once turned fields into geometric grids, with rows spaced for water and seeds dropped at measured depth, becomes invisible. No plow fragments with attached tubes survive. No scribes copy the old engineering manuals. The great temple economies, which once coordinated labor, water, and seed with bureaucratic precision, fragment under new regimes. When the canals silt up and the palace granaries empty, the system that preserved and transmitted technical skills collapses with them. What survives is only the memory of abundance, not the means of producing it. Later, farmers return to scattering seed by hand, accepting losses that their ancestors had engineered away. Yield ratios fall. The harvest-to-seed ratio reverts to 3 or 4 to 1, numbers that echo the inefficiencies of pre-plow agriculture. The silence lasts for 35 centuries. A machine that once fed cities and filled temple storehouses is erased so completely that when it is reinvented millennia later, it is hailed as something new. The original inventors remain unnamed, their achievement unacknowledged, their civilization credited only in fragments and shadows. In 1701, Jethro Tull patented a machine that would transform European agriculture, a horse-drawn seed drill driven by a rotary cam. Tull's device cut a furrow, dropped seed through a calibrated tube, and covered it in a single pass. His patent described a mechanism to meter grain at precise intervals, ensuring uniform depth and spacing. The engineering logic is unmistakable. A controlled seed flow synchronized with the movement of the plow delivered the grain directly into the soil. The result was higher germination, less waste, and easier weeding, exactly the principles that defined the Sumerian cedar plow 3.5 millennia earlier. Tull never claimed inspiration from the ancient world. By every account, this was an independent reinvention. Yet the functional match is exact. The same solution rediscovered after 35 centuries of silence. A Sumerian hymn carved into clay credits the god Enlil with the gift of agriculture. The lines read, "Enlil, Lord of the Winds, bestowed the plowing tool and the seed tube upon the farmers. He taught them the order of rows and the measure of grain." The scribe's hand records no inventor, only a divine origin. This mythic attribution, repeated in temple texts, blurs the line between engineering and revelation. Was the knowledge of the seed drill preserved as sacred tradition, or did the claim of divine authorship help erase the memory of human innovation? The question lingers in the silence left by the vanished machine, a civilization's greatest tool, remembered only as a gift from the gods. Today, engineered seed drills power global food systems, yet the precision logic behind them was carved into Sumerian clay 5,500 years ago and then lost for millennia. That silence reshaped history. The real marvel is not the machine. It is how a civilization can invent the future, then vanish from credit.